Okay, good day everyone. Today in our discussion in descriptive inorganic chemistry, we are going to talk about hydrogen and hydrides. First of all, my name is Juan Benigno A. Luarca, the speaker in this discussion. Okay, now, what are we going to expect in our discussion today? So, the coverage of our lecture will be covered what is the element hydrogen, what are the common compounds of hydrogen, what is hydrides, and what are the different kinds of hydrides. Now, let us talk about hydrogen. Now, hydrogen is one of the most famous elements in the periodic table. Hydrogen is a chemical element with the symbol of H with an atomic number 1. Hydrogen is the lightest element at standard condition. Hydrogen doesn't exist in a own form or by itself, but it is a diatomic molecule, which means that you will not see an element of hydrogen as H, but as H2, because di means 2, with a formula of H2. It is colorless. Hydrogen is a colorless gas. It is odorless also. It is tasteless. It is non-toxic, but it is highly combustible. When hydrogen is mixed with an oxidizer such as oxygen, it is a very combustible gas. Now, hydrogen is the most abundant chemical substance in our universe, consisting roughly 25% of all normal matters such as stars and even the sun are mainly composed of hydrogen. Hydrogen is in a plasma state. Now, hydrogen exists on Earth in a molecular form. The most famous or known compound of hydrogen is water. Also, inorganic compounds. For the most common isotope of hydrogen, each atom has one proton, one electron, and no neutron. Now, let us talk about the isotopes of hydrogen. Now, there are three kinds of isotopes. There is the protenium. Now, protenium is the first isotopes of hydrogen. It is one of the common isotopes of hydrogen. It is plenty in nature. Its abundance is 99.98%. One of the reasons for this is that the nucleus in these isotopes consists of a single proton. And this proton at no time, it has been reported to decay the mass of protenium in 1.00782 AMU. Hydrogen is generally combined with other atoms in compounds and usually found as H2, as a diatomic molecules, like what I said earlier. Now, the second kind of hydrogen or isotope of hydrogen is the deuterium. Now, deuterium is a hydrogen isotope consisting of one proton, one neutron, and one electron. It has a major application in nuclear magnetic studies. Now, another application of deuterium is on drugs, in nuclear weapons, in contrast properties, and in nuclear reactor in nuclear power plant. The other isotope of hydrogen is the tritium. Tritium is a hydrogen isotope consisting of one proton, two neutron, and one electron. It is a radioactive isotope of hydrogen with a half-life of 12.32 years. Okay, so that is the isotope of hydrogen. Now, dihydrogen monoxide, commonly known as water, with a formula of H2O. This is one of the most abundant molecules or compounds of hydrogen in our planet. Now, water is a inorganic. It is transparent, tasteless, odorless, and nearly colorless chemical substance, which is the main constituent of the Earth's hydrosphere. Now, all living organisms, even mankind, animal, plants, and even bacteria, need this compound to survive. All living organisms use this as a fluid in their body. Now, water is also acts as a solvent. It is vital for all known forms of life. Even though it provides no calories or organic nutrients, it is very essential for living organism, like what I said earlier. Also, I want to add, hydrogen is known as the universal solvent because it can dissolve many solutes such as salts. The common solute that is dissolved in water is sodium chloride, which we can see in our seas or in the ocean. It is a solution of sodium chloride. Now, it indicates to each of its molecules containing of 1 oxygen and 2 hydrogen atoms. Now, the bond that is used here is called a covalent bond. A covalent bond is a bond of a nonmetal with a nonmetal atom. Now, hydrogen atoms are attracted to the oxygen atom in an angle of 104.5 degrees. Now, water is the name of the liquid state of H2O. Now, at standard condition and temperature and pressure as well, water is in a liquid form. Now, other common compounds of hydrogen that we usually use, like what I mentioned, first is water, and another is ammonia. Now, ammonia, I have here a molecule of ammonia, as you can see here, display with a ball and stick model. You can see a blue ball with white ball connected. That is ammonia or NH3. Now, ammonia is usually used as a cleaning agent and sometimes used in the medical field to wake up unconscious patients. Another is methane. Now, methane is known as a very simple hydrocarbon gas. Now, this is a combination of carbon and 4 atoms of hydrogen. Now, table sugar, are some organic molecules, excuse me, some organic molecules with a formula of C12H22O11 that we use in our food, such as in our cakes, in our dishes that we want to make it sweet. Now, hydrogen plays along there also. With that, in addition, hydrogen peroxide. Now, hydrogen peroxide, or we also known as agua oxinada, hydrogen peroxide with the formula H2O2 is used as a cleaner or as a disinfectant in our wounds. So when we are a child, usually we can see our mother putting some liquid in our cuts and our bruise. That is hydrogen peroxide. That kills the bacteria to prevent infection. Another common compound of hydrogen is hydrochloric acid or HCl that we known in the common name of muriatic acid. Now, muriatic acid, usually we use that in our toilets. But did you know that we also have hydrochloric acid in our stomach? Yes, our stomach has a dilute form of hydrochloric acid that helps us to digest food. Okay, now let's proceed to hydrides. Now, what is a hydride? Hydride is an ion of hydrogen, or more commonly, it is a compound in which one or more hydrogen center have a nucleophilic, reducing or basic property in compounds. In compounds that are regardless of hydrides, the hydrogen atom is bound to more electropositive element or group. However, the basic metal hydrogen bond polarity causes the hydride to react vigorously with water, often in a reversible manner or reversible manner, I mean. Now, hydrides is a compound of hydrogen with another atom. Like the picture shown here, I have here a sodium hydride. Yeah, sodium hydride with a formula of NaH. So as you can see, the color purple represents the sodium ions and the color white ions represents the hydrogen. As you can see, there is a ionic bond in that. Now, what are the kinds of hydrides? There are three kinds of hydrides. We have the ionic hydrides, the covalent hydrides, and a metallic hydrides. Now, I have here some models of hydrides, such as propane or C3H6 and ammonia with the formula of NaH3. Now, we will put emphasis in these three kinds of hydrides. Now, let us first know what is ionic hydrides. Now, ionic hydrides, our first category of hydrides are ionic hydrides, also known as silene hydrides or pseudohalides. Pseudohalides. These compounds form between hydrogen and the most active metals, especially with alkaline and alkaline earth metals of group 1 and group 2 elements. In this group, the hydrogen acts as a hydride ion, H negative. They bond with more electropositive metal atoms. Ionic hydrides are usually binary compounds. Only two elements in the compounds are also insoluble in solution. Now, ionic hydrides, this is a bond of hydrogen in the first group of the elements and the second group, which is the first group is the alkaline metals and the second group is the earth alkaline metals. Now, when a hydrogen reacts with a metal in a group 1 metal, let's say for example, put sodium. It just needs one atom of sodium and another atom of hydrogen, or just one atom of hydrogen to produce NaH or sodium hydride. But in the group 2 or in the earth alkaline metals, they need two hydrogen to produce an hydride because group 2 elements are positive 2. So they need two hydrogen to become stable. So for example, we have calcium hydride. Now, we will have the formula of CaH2. Okay? Now, we also have the covalent hydrides. Again, covalent is a bond with a nonmetal with a nonmetal atom. The second group is the covalent hydride, which is when a hydrogen atoms and one or more nonmetals form a compound. This occurs when hydrogen covalently bonds to more electropositive elements by sharing electron pairs. This hydride can be volatile or non-volatile. Volatile simply means being rapidly to be vaporized at low temperature. One such example is the covalent hydride is when hydrogen bonds with chlorine to form hydrochloric acid. Like here we have the formula of H2 and C2. These two atoms are both diatomic molecules. Now we have here 2 atoms of hydrogen and 2 atoms of chlorine. When they react, it will produce 2 molecules of HCl. Now HCl is a gas. Just to clarify, HCl is a gas, but when it is blown in a water, it can dissolve to produce hydrochloric acid. Another example is ammonia. When hydrogen reacts with nitrogen, it produces ammonia or NH3, like in the equation below. That is also a gas. Now, if that is dissolved in a solution, like for example, it is dissolved in a solvent of water, we will have a ammonia solution. But these 2 gases is not a liquid in standard room temperature. It is a gas. Okay? Now, the hydrides of nonmetals of the periodic table becomes more electronegative as you move from group 13 to group 17. It means that they are less capable of donating an electron and wants to keep, because their electron orbitals becomes fuller instead of donating of H negative. They would instead donate H positive because they are more acidic. Okay? So that is the covalent hydride. So we have here an example, the hydrogen chloride. Another form of hydride is the metallic hydride. The third category of hydride is the metallic hydride, also known as interterrestrial hydrides. Hydrogen bond with transition metals is one interesting and unique characteristic of this hydride. These hydrides they can non-stoichiometric, meaning basically that the fraction of H atoms to the metal are not fixed. Okay, not like for example the silane halides or silane hydrides, I mean, that in the earth alkaline, it has a ratio of 1:1. And in the earth alkaline metals, it has a ratio of 1:2. But in the metallic hydride, it is non-stoichiometric. Okay? It is non-stoichiometric. So it means it is not fixed. So it's either can have more metals or less metals. Now, the idea and basis for this is that the metal and the hydrogen bonding, there are crystal lattice that H atoms or hydrogen atom that can and may fill between the lattice, which some might and is not definite ordered filling. Thou is not a fixed ratio of hydrogen atoms in metal. Even some metallic hydride consists of more stoichiometric compounds as well. Now, let us just summarize. In the chemical bonding in our ionic hydride, we have here a ionic bond. Okay, we have here a ionic bond. Now, the atomic composition of this ionic hydride is a combination of hydrogen to a highly electropositive atom in the group 1 and group 2. And in the covalent bond, we have a chemical bonding here of covalent bond. And the combination of hydrogen of a combination of hydrogen with a comparably electronegative nonmetal such as chlorine, bromine, iodine, and fluorine from group 13 to group 17. And in the metallic hydride, it is a combination of hydrogen with transition metals. Now, some uses of the hydrides. Now, ionic hydrides or silane hydrides are used as a base, occasionally as a reducing reagent in organic synthesis. Now, ionic hydride such as sodium hydride or lithium borohydride is commonly used in organic synthesis in organic chemistry as a reducing agent. Typically, solvent for such reduction are either water and another protic solvent that cannot serve as a medium for ionic hydrides because the hydride ions is stronger base than hydroxide and most in hydroxyl ions. Another use of hydrides, specifically in metallic hydrides, hydrides are used as a reducing agent in chemical industries in battery storage, such as nickel hydrides, batteries, and conducting electricity, producing hydrogen. Hydrides are also used as a drying agent. So if you have a solvent with some water impurities, we can use some hydride, commonly sodium hydride, to dry that reagent, to make it, to remove the water as a contaminant. And heat and hydrogen storage, as well a strong base for organic synthesis, like what I said earlier. So that is all. Thank you for listening. If you have any question regards hydrogen and hydrides, you may comment on the comment box below and I will answer your question regards hydrogen and hydride. So thank you very much. Good day and keep safe to all of us. Thank you very much. Stress ako.